to make your bun? How do you make it?
What? Okay, I'm gonna like be falling my eye out.
We couldn't make it.
No, like
Really? Trust me, you'll be surprised about what they made.
Like,
I don't care about 70. What?
all right.
You know, maybe the letterpress in downtown Morgan. Well, my mom.
No, now I'll pay attention. I'm gonna go to downtown. Should go like I'm that way.
I didn't go out there. I packaged cards and grades.
All right.
And then I put away pens.
You guys are gonna be excited by this.
No, we're not.
Yeah.
Today and tomorrow and probably maybe Wednesday, we will finally get more into no permutations and combinations.
What?
I'm sorry. What?
Did you
I
say
thought you'd
when
be
I know
excited.
this?
We've talked about these things like mildly before.
Yeah,
Like,
I did.
it's like the difference between an order of books on a shelf or like the differences in whether order matters.
Oh God.
So
That one
after this
terrified
week,
me.
you'll totally understand this stuff.
Yeah, but it would have been helpful to know it earlier.
Okay, I'm sorry, we can't teach everything all at once.
That'd be
You
great.
can do everything all at once. Right now, Mr. Hudson. Go.
Right now. So we're gonna skip a bunch of this. We're gonna try to cover 2 lessons today. If Nick's phone, which many of you iPhone users have been going through password changes recently, if Nick's phone is prompting him, if you upload or if you update your Apple software, you have to have a 6-digit passcode as opposed to a 4-digit. I know, because your generation's crazy. But
No, I said
you,
my
they,
no,
no, but you can't use a 4-digit now.
I thought you could just put an option thing that changes it for you.
Well,
Oh,
isn't
yeah.
there an option where you can choose your passcode? Because I have a 5-digit.
I think it's requiring a 6-digit now. That or just made my wife do that and then she left it. But either way, I don't use that one. So, if Nick's phone was requiring a new password, and it says choose any digit 1 through 7. Yeah, right? 1 through 7. It's a weird phone. It's like, it's one of those, you buy it at the dollar store. So, how could we figure out how many total password combinations?
What sort of phone is it? This would be like 7 times 7 times 7 times 7.
Why?
Because
Alright, so we actually need to focus. Because it's a math book. Come on, don't ask questions that we all know the obvious answers to.
Would it be like 7 to
there's
the
10
7th
buttons.
power?
Okay, stop analyzing the phone. If I need to cut pictures out of this, that would be really childish. Ava said 7 times 7 times 7 times 7. Why?
74. Because there are 4 spaces and there are 7 options for each space, and assuming you can repeat them.
So this is going to be called by CPM a decision chart. How we make decisions on number of combinations. Now, aside from having a fancy name, this is exactly how I've always done it ever since forever, so don't groan about it having a name that CPM, I mean, I just never had a name for this. It was just like set up the probability thing. So we say, okay, the first digit has 7 options, the second digit has 7 options, the third 7 options, and the fourth. And then we multiply these for obvious reasons. The misconception that the book says, like students might think, and you guys never really go that route, but we obviously multiply instead of adding, because if you are just trying to guess what to do with the numbers, somebody might say add, and we know that as you increase the number of unnecessary, especially in equal.
We already had a probability unit.
I know, but we're about to go deeper. So when we then we're skipping this. Now this. So game contains 9 discs, each with numbers 1 through 9 on it.
This is where we bet.
Yeah.
This is where combinations and permutations comes into play.
Different 3
How?
There's 9 discs.
There are 9 discs.
And each of them has a number according to the disc. 3-digit number can be formed by
Each with one number, 1 through 9.
So it doesn't really matter that there's 9. It's just based on numbers 1 through 9.
Yeah. Numbers 1 through 9 are floating around a pool or whatever you want to think. How many different 3-digit numbers could be formed?
Do the same.
Wait.
9, 9, 9, 9.
You gotta think about this. You pick one disc first number, one disc second number.
Oh,
one
because
disc.
you're eliminating them. That's weird.
So there's
Oh.
Because in the first one you were allowed to repeat.
but you can't.
This one you
Yeah.
can't.
How would you do
Nine,
9,
what are you looking for?
8
Like
times
my
9?
pencil or something?
No, I haven't.
Would you do like 9 times 9?
Calculator?
9. Would you do 9 times 9 times 9 and then like subtract it by something?
Or 9
to
times
take
8
out
times
the amount of numbers that you can't keep the same.
Oh, we can make a sequence.
I like you guys are really good at conversation.
Wait a minute. I think
Eventually, I
We need to use
Wait,
perfect.
wouldn't it be 9 times 9 times 9 because we're getting 3
Oh my
numbers
God.
and there's always 9 options?
But there aren't always 9.
So, make a decision chart. We are selecting 3-digit numbers. So, this is not B or C, but I'm going to write it down here.
Is that a decision chart?
Oh, because
Yes, we're first choice, second choice, third choice.
So it would be 9 times 8 times 7.
Ah, so Ethan has now changed his mind.
I forgot that there's like actual this.
If I pick one and don't put it back, like we've talked about with card decks and things like that before. But when we've talked about this non-replacement situation, it's only been dealing with the probability of something happening. This is now setting up how many options are actually in existence. So I have 9 options when I choose my first digit. There is no replacement because it like goes on a board or something. Like, here is your first, now choose again. Then there's 8 choices, and then there's 7 choices.
If we knew that, we could have totally got that question.
Yeah,
I knew it.
I didn't understand.
I got it.
Wait, what question?
The question from Smash House.
Oh, dang it.
We totally could have gotten that one right if we
I
knew
know,
that.
we
So, hold up. Now that you know that, check out situation B.
Great. More lotteries.
Oh wait,
The lottery is, I mean, someone's gonna win, but it's not a good way to spend your money.
Unless
wouldn't that one be 9 times 9 times 9? Just
Yeah.
I thought you were a question.
Oh, right. Okay.
Yeah, that would
Just saying it.
That would be nice.
It's the same thing as that one.
No,
Time.
no,
Wait,
no,
no.
no.
That's one the numbers don't go away.
That was a quick reaction, guys. Thank you very much.
Sorry.
Okay, now can somebody politely tell me why it's not the same as Ed? Colin.
So, when you spin a wheel, when you spin it and you land on a number, the number or slice usually doesn't go away unless it's taken away by someone for the game show, but that's different, but that's not part of the problem. So, you never do actually lose a number option. Yeah.
So it's the same thing as the 12-1.
No, because that's 7 and that's to the 4th power.
No,
Yeah.
it's similar version.
Same
It's a
concept,
different
yeah.
version.
So this had 504 different options. B,
720.
yeah, has 729 different options.
How much money would like would a lottery ticket cost? Like, I'm just trying to do some.
Just like $1.
It depends on a lot of things. First off, how much? Yeah, like what
I'm just saying
percent
for
of?
for single, like a single.
I mean, so like the Mega Millions jackpot that will happen, you can buy tickets for like 2 or 5 or 10. Like, it's just how many draws you want to choose. So it's like $2 per draw, like set of numbers. So then if you pay $10, you just get 5 sets of numbers, or there's like different pricing.
I just wondering because I was trying to figure out the probability of like, not probability really, like saying how much money would cost to buy it and see if it would actually like to buy all of them without costing
Right.
more than like $1 million or.
All right, so if you're planning a schedule and you have the classes English, Physics, Government, Pre-Calc, Spanish, and Journalism to schedule, and let's assume that this is an amazing school where scheduling will never conflict and never be restricted. How many possible schedules can be made for Marcus? How do we do this one?
Oh.
It's the same thing as the
Same
other one.
concept.
Well, similar to the other one.
Now wait, I hear 2 different things.
6 factorial or 6 times 5 times 4.
Oh, so
I
it's
also
six
heard 6
factorial.
times 6.
Oh no, it's 6 times 5 times 4 times 6.
6
That's
factorial.
factorial.
So this reminds us
That's exactly that's what factorial.
of 6.
Yay!
Right, 6 factorial, which is
6.
no, it's 6 factorial.
No, I know.
6.
Aggressively screaming.
Miss Rosie, you know all about 6. Don't you?
No.
6 factorial.
No.
Thank you very much.
No, not
It is not angry mathematicians.
I know.
I was one. Oh,
It is multiplied. Oh my gosh, you guys and your pink calculators. So 6 factorials, or factorials. 6 factorial. What is it? 720? Yes.
well, okay, so
There is
6
a
times
button
1
in
is
there.
6.
There is a button. Okay.
Five times 2 is
Hey, there is a factorial button. It is in math.
Oh, really?
Hidden.
Yeah.
Wait, isn't there a bit like
I went the long way.
Oh, it's in the probability
6
part.
times 1?
I wonder why that is.
Oh.
Which is it under?
It's under
math,
it's under
Dude,
math.
I've been telling you guys for a long, really basic computer. Okay, they didn't like make things tricky. It is a probability function. It's housed in probability. All right.
Oh, yes.
So, if Marcus, let's say, then how many schedules are possible if pre-calc has to be first period?
Oh my goodness.
5 factorial.
Yeah.
That's not factorial.
Because it's 5 4
Yeah.
Which is how many? How much does that change it?
That
120.
subtract 600.
That subtracts 600 of the possibilities? That's insane.
Oh, wait.
Now wait. Knowing that, what's the probability that he has pre-calc first period?
1/6.
How do we figure that out?
There's 6 classes.
Yeah.
There's 6 options.
Yeah.
And
Okay.
you have to have
So-
one of them.
That's the simple way, right? But this is trying to get you to understand how to use this in a more complex manner. So imagine, yeah. It's trying to get you to work.
Oh, so how many of those options does he have pre-calc per period?
So what it's actually trying to get you to, and these guys up here said it because they weren't laughing, they were thinking more deeply. 5 factorial over 6 factorial. Which, yeah, we then know becomes 1/6. And knowing that is going to help us with more complex problems as we have to remove situations. So you know factorial.
Oh, no.
Bless you.
That was a call.
Bless you.
Thank you, Connor.
She just wants to bless you.
I'm sorry.
Or you can like do 9 factorial, you can write it out and then you can cancel out like the numbers. Like
Remember,
that.
you do some
How
basic
it is calculated.
calculation.
So,
Right? Yeah.
try ABCD here.
Sometimes following expression
Let's see who can do this.
without using the factorial function in the calculator.
What the question is this? Oh, okay, got it.
Oh, yes.
Oh, wait.
No exclamation point allowed.
I'm gonna write it all out.
Some of these you shouldn't even need a calculator for.
Yeah, but once you get it's actually wait, that's not.
There's a couple large-ish multiplications.
What is 7
You just multiply them together.
We mean multiply.
Like on C, the denominator is 4 factorial. So is that just multiplication?
I was just like 2 digits.
So what is 4 factorial?
4 times 3 times 2 times 1.
And then 3 factorial.
3 times 2.
6 times 7.
So you just do that.
Yeah. So you multiply all those values together.
Okay.
But you don't need to. Like here, look at the easy way to do these problems.
No.
So if you have a 7 factorial on top, and a 4 factorial and 3 factorial on bottom, things will cancel.
7 will be exclamation points. So bad.
So for
Factorials
A,
are weird.
Gunner, think about A, numerator, being 10 times 9 times 8 all the way down to 1, right? Denominator,
I'm double checking my work.
denominator
Jenny.
is 8 times 7 times 6 all the way down to 1. what can I cancel out in those multiplication sets?
1.
Okay, the stacked ones.
All of them. No, all of them. That
1 and
Hold on.
are overlap. Like 2 times 2 over 2 is just.
I was
Yeah.
doing that right.
Whoa. So what's the multiplication you need
Uh-huh.
to do?
10 times 9 over 8. No,
10 times 9, that's it.
Wait, why?
Because
10 times
everything
9,
cancels
because
out.
because 8. Okay, so 8 times 7. Can I show this?
Yeah.
James.
Guys, especially for the rest of the year, I don't want to teach. If you want to teach, do it.
So basically,
Okay, that's a joke. I do want to teach, but I'd much rather let
Factorial
you
equals like 10 times 9 times 8.
Yeah.
Whoa.
That's
Okay.
pretty
And then
over 8 times
and then
7 times
8 factorial.
is. Why are you writing so much?
Okay, you get okay. So 8 factorial down here. 10 times 9 times 8 times 7. Okay, so this stuff is the
it
same as
cancels,
this
it
stuff.
cancels out the bottom.
Okay,
then
so you
it's just
cancel
10
this
times
out, and then
9.
you're left with this.
Now, as much as you don't want to hear this,
That's interesting.
giant one. You've got a ton of giant ones there. Hey, don't break my smartboard. It's already bad. No, you're not. You're not sorry at all.
It's perfect.
So what's B? What math do we actually have to do in B?
70 times 69.
70 times 69, which is a bit larger.
Yeah, but that's much nicer.
A bit larger.
That's why I was saying, like, you might not need your calculator for these. Now, C, a little bit more interesting then.
very confused.
7 factorial over 4 factorial
You just
times
write
3
it out, and then you
factorial.
cancel it out.
So then what's it actually turn into?
7 times 6 times 5 over 3 times 2 times 1.
Mm-hmm. And
Because, okay, see, when you write it out, you can, like,
3
just
right?
cancel stuff out. There.
so the 7 factorial works with the 4 factorial, leaving just 765. Because the 4, 3, 2, 1 cancel out with each other. This 3, 2, 1 is still there, but another really easy thing to do, the 6 and the 3, 2 can cancel.
Oh.
So it's really just 7 times 5.
Over 1.
So what's 7 times 5?
Over 1.
35.
Over 1.
Okay, yes.
Actually, it's back to 1 times 1 times 1.
Remember how we've talked about mathematicians being efficient?
Yes.
We don't say things that are unnecessary, just like you don't write things.
It's probably the same thing.
Except more. I don't know, my dad just got
So what math do you end up needing to do here?
10 times 19.
What are
10 times 19. Over 1.
Well, yeah, but like,
Because this becomes 20 times 19, and then we still have, because the 18 down to 1 cancel. Are we okay with that? This then still has 2 times 1 for the 2 factorial, but the 20 and the 2 can reduce, so the math that's actually needed here is just 10 times 19.
Why does
The
it
over 1 is unimportant.
So it's 190.
So it's 190. All right, we got to keep rolling. Are there any questions there? Or anything we just did?
I love
The factorial reducing. If you need to, write them out, and then it will make sense. Like, do a couple written out, and it will make sense.
Jenny
So-
wrote like out the factorials and then like.
Okay, I want to do it myself.
Okay.
So, we got to keep rolling,
Sphere.
because we're ever going to finish this.
question like that on
The sphere cone demon question.
it was so easy.
By the way, the
I
reason
was
we're not,
for me.
hey, the reason we're not going back into chapter 11, because somebody asked earlier, like, what happened to unit 11, that, the lessons we didn't do are essentially like surface area and volume of cylinders, spheres, cones, and
That's not really
pyramids,
hard.
which essentially it's, hey, here's formulas that we're going to discover and then just use. And in your life, it's going to be, hey, use the formulas, and you all know how to do that. I mean, we essentially
Use the
skip.
values and use the calculator.
Are we gonna actively dive back into it again during the
Yeah.
rest of the book or no?
Look under.
No, you'll almost always be given the formulas.
Okay, I was like, we're just gonna. I'm like,
All right.
next year you can figure them out.
Yeah, just use formulas. All right, permutations. Permutations include the different arrangements, where like arrangement matters. So, a flush. Who here plays poker?
I'm not very good at it.
I don't play it, but
so never mind. That's not gonna help us.
He just has to play poker.
No.
It's not.
There is lots of
We can learn how to
but
count
we'd rather
cards.
play
We can learn
21.
how to count cards.
That's blackjack. We count cards in blackjack.
Yeah, but still.
Not
It's,
cards of BS. It's really fun. What? Oh, nothing. Altoids are really good.
Guys, I get that it's April and it's almost May, but I essentially have 12 days left to teach you. So, by the way, do we have class tomorrow on Wednesday?
yes.
Yes.
Math class?
Oh,
Yes.
see, no way.
The only class
We
we're
don't
missing
have
is
Spanish.
Spanish.
We don't have Spanish.
So I think
Wait,
we're
what?
gonna have
We'll
it.
come at a regular time.
Yeah, I think we're gonna have it at the
Oh,
same
wait, we
time
have
that we
the
did the
midterm
week
and stuff.
before.
Yeah, midterms.
And travel.
We
So
only
that'll
have
be
3 weeks left.
So we'll have it
Oh,
first,
just school.
I think.
What?
Because that's what we had it beforehand. That's what we had
You'll
it
have
for
math.
second testing.
What do you mean you'll have it first?
Like on our schedule,
What?
our schedule at least, we have it. So
What
we
time is that?
12:33 to 1:17.
So the normal time.
Yes.
We'll have it here.
I'm not good at times. So.
I just leave when the teachers tell me to. I know the approximate times of our class.
So, if we're setting a pin in an ATM, and let's say for security reasons they won't let us use the same digit twice,
What? That doesn't seem like it.
there are weird rules as you get into passwords on computer systems and stuff. There are very weird
Why
rules.
did they care? You should be the one who cares.
Because their job is to make sure that you don't get like your identity stolen.
Whatever.
So, how many pins are possible? You want an actual and a value.
A lot. Cannot
Or
repeat.
digits.
Cannot repeat.
So 9.
4 digits.
times
9
nine.
times 8
9
times
times
7
8
times
times
6.
7 times 6.
Yeah, then
Three
the number 0.
Oh,
3,000.
10 times 9 times 8 times 6.
Oh, right, 0. Yeah.
Wait, times 0?
No.
Zero is a
times-
digit, right?
Yeah.
Yeah.
It doesn't have-
I didn't
it
know
doesn't have
it was zero.
numbers are.
Oh! Wait.
So it's just 10 times 9 times 8
There
times
1, 2, 3,
So
4,
5 times.
Yeah.
5 times
10
8.
times 9 times 8 times
Because
6.
there's 10 possibilities.
Oh!
I hate when they do
Oh.
this. They're like
5,040.
That's what I already said.
So it's 5,000.
I did.
5,040. I'm not
Hey.
smart.
So, what they're trying to get you to here is understanding how we can make this into a formula. I don't know if I would you rather. Do you want to play with it and try to figure it out, or you want me to give it to you?
Teach
Wouldn't
us.
it just be 10 factorial over 10 factorial?
So 10 factorial over what?
6
6
factorial.
factorial.
How do you get this?
Well, those are
Minus
numbers
the
on
number of number of
Yeah.
We
numbers.
do the
you
number
get.
of digits minus
Number of numbers
the
you get?
number
Burner,
of-
Yeah,
you're
that's
leaving
what I
us right as it gets important.
The number of digits minus the number
Hold
of
it.
spaces.
You're
Number
okay.
of digits, number of total digits minus the number of
Go
spaces.
faster.
The
You're
number
gonna
of
miss, like,
options
4
minus
minutes.
the number of
Copy it and come back.
spaces.
Spaces.
Yeah.
So then,
Digits you
Choices
get.
over the chase. I can't remember.
Options
Yeah.
over spaces.
Options over spaces.
There's probably a better way to say
Options
it.
Options
over-
Divided by.
Options
No,
over
minus.
options minus spaces. Yes.
Because
Okay.
there's 4 things take. Oh, space. Oh.
there's
On the regular high school class.
So I wonder. I forget how quickly we get to. Actually, let me look.
Wait, this kind of like that one formula. It's like where it's like the. I forgot what they're called. It's like parentheses and there's 2 numbers one on top of the other, but there's no like bar or anything. And then there's like a thing where you take like for the top number it's like factorial of that, and then the difference factorial plus the factorial on the bottom.
I'm
Jenny,
very
I'm
confused.
scared. Just let you know.
The first thing I think of is the limit.
It was like to solve something.
Yeah, there's another one.
Let's just solve like that sigma.
Yeah, let's answer these questions.
That girl is very happy.
Yeah, that girl.
This will help lead us to figuring this out. So check out number A. We know what a permutation is. We now kind of know how to work with the math. Try these out. Work through A through D. I'll scroll.
Oh. 52 people.
I wrote 52I.
I'm feeling, so I'm just gonna put that.
How many?
I don't. Just no.
Remember, runner-ups are non-winners.
That's the big one.
Oh, so that broke the one he had. I like the other logo better though.
Like
Jenny, stop.
not even a million.
Oh,
100.
right.
got it.
So how many winners are there?
52 times 51 times 50.
There's one winner?
Well, one winner,
There's
4 people.
3.
Yeah, there's
Oh,
four.
my
Oh, the best and the three next runner-up.
There's
Oh,
3
I thought I saw.
first, second, third.
No, you're just figuring first.
Best logo and first, second, third runner-ups. Runner-ups are not winners.
I thought
First, second,
best logo
third, runner-up.
first,
I thought
second,
it was
third.
No
first,
one,
second, third.
no one
These
ever
three.
recognizes fourth place.
Yeah, why are they?
So why are they doing it?
That's weird, bro.
No one ever recognizes fourth place.
The fourth place person even
Well,
isn't
it's
even
the
holding
third
the logo.
runner-up, and they do that sometimes, actually.
Why?
She's not
Because,
even
like, you
holding the
win,
logo.
and then you 3 people are the best 3 non-winners.
It's like yesterday
If
when
you don't ask me, we're just answering some questions.
I'm surprised you didn't
Yeah.
Russell
Oh
got
my.
Jenny, for your tennis tournament.
So if we get done with this early, you get to work. So what division could we set up here to quickly write this? Like, if we wanted the most efficient way that we're going to type this in our calculator, we know that if there's 52 contestants, I know that you guys are smart, so you know to set up 52 times 51 times, and there's 4 places. So if we set up a decision chart, sure, we can do 52 times 51 times 50 times 49. But there's a quicker way to write that, and quicker way to compute that.
Don't you just do 61 times?
It's like the tennis tournament.
52 factorial over
48.
48 factorial. So again, we see the number of total possibilities.
The best logo and.
I said 4 positions, like 4. So the volleyball team is sponsoring mixed doubles Sandcourt, and the pair signed up. 16 of them have a shot for 7 trophies. Yeah, I know.
It's weird number, but it's also
Colin?
really big.
There are
number.
a lot of options. I computed it.
Okay. How do we do it? How do we set it up?
That would be 16.
Yeah.
Over. I want to say 9 factorial. 9 factorial.
I think.
9.
Yeah, 9 factorial.
Oh, and then you can. Oh, okay. I see.
It's big. Look at this big.
I got 5, 7,
And
6,
C,
5,
anybody
7,
wanna help
6, 0, 0.
What'd you say?
Getting a locker.
C, anybody want to?
Oh, okay,
Let's look at
so
C now.
35 times 30. So 35 factorial over 32 factorial.
I think the numbers
Wait a
should be allowed to be
Wait.
repeated.
0,
They
35. There's 36.
Zeros.
Because 0, 30, 35.
Oh,
Jenny's arguing there's 36 digits.
I understand.
But in the actual blocks,
So
it's
Zero.
0 is like
Zero.
factorial over 30.
Zero is ugly.
Over 33.
Yeah.
Wait, but the 0 and the 35 usually overlap.
Yeah, they overlap. So it is 30.
35 and 0.
Just stop. This is pure mathematics, okay? There's no like situational bias.
What are they doing
No.
with overlap?
They're saying that the 0 and the 35 are supposedly the same number on the block. Which
They
I don't
are.
think they would denote both numbers. Like, there probably is no 35 then on
There
your
is
lock.
the mark 35.
We don't know what this is. This could be like, I don't know, typing or something like that.
I know. My mark actually goes up to 39 and then
There you go, yeah.
35 and 0.
Yeah, because my
So
last,
that'd be
then
40
last
numbers.
number of my combination.
So yours are
Those
1
numbers
to
actually
40.
can be repeated.
Yeah.
D.
If you actually
Or 0 to 39.
Oh, none of the. Oh, so just. Oh, wait.
Yeah, now it gets weird.
No.
Wait, but it can be used for the other digit, so it's 35 times 35
Yeah, 35,
times
35,
34.
34.
Are we sure about this one being 35?
Yes.
Yeah.
Okay,
Yeah,
why?
'cause that's how many
Because
options
you
there
add
are.
Ryan?
zeros.
You get rid of the one you used for the first one, but now you can use zeros, so that adds
Yeah.
another
Ah, so if I choose 9 here, I can't use 9 here, but now 0 is back in play.
And then, but then you have 34 options. So 34.
My gosh.
So it's
Simple.
41650.
That simple rule got rid of 1,190 possible
35 times 35 factorial over another.
So that is a situation where that's probably the most efficient way to write it. And how many 3-number locker combinations can she choose from 0 through 35 and can repeat any number?
Is it still the 0 cannot be used the first time, or is it?
No.
You just choose whatever.
Choose whatever.
Any
So
number.
46656.
So you could do like 35, 35, 32. I mean,
No,
you
you know,
could
like, how can you, like,
36.
oh,
spin the other direction and go back to it.
36 cubed.
Yeah, it's 36.
Which would you recommend like we write it 36 cubed, or would you recommend we write it as like the full?
I can write the actual answer.
Just saying, like if it's.
I mean, if you want to write it using this the decision chart, that would be sweet. You don't have to. So this is this a permutation? This last
No,
situation.
because permutation.
Good afternoon, Piper Beth and Nathan Hayhurst. Please come to the office. Piper Beth
Wait,
and Nathan
when
Hayhurst.
did we say permutations don't allow repetition?
Yeah.
The one here, the definition, it says permutation does not allow.
It's over one.
I thought order mattered. I thought all we knew about permutation was that order mattered.
No, up here it says in parentheses an arrangement that does not allow repetition. I'm going by the book here.
I know.
I don't know anything
So
else.
this is one of those things where as I've worked through CPM, I've kind of learned some things. 4 or 5 problems about permutations, an arrangement that does not allow repetition. So my understanding of permutation back from my learnings was order mattered, whereas combination was just like order doesn't matter. Like how many combinations, like outfits of clothing. Well, it doesn't matter if I pick out my socks and then I pick out my shirt, or I pick out my shirt and then I pick out my socks. I'm just one combination. But the order of the books on the shelf, right? Permutation, order mattered. But now they're saying we cannot repeat.
It's the same thing.
So is E a permutation?
No.
No. Even though E still has order mattering, like it is like it's a combination lock, right? Order matters. Even if the numbers repeat, order matters, but it's not a permutation. Cool? So it's not a, I mean it is a combination to the combination lock, but it's more complex than a combination because order matters. Alright. So order matters and items can't be repeated.
This is a permutation.
So here's all the combinations possible, right?
Okay.
X, 6, 9, 3, 7, 3 cubed.
I think we're having choir practice on this side of the room.
It's,
Let's do it.
It's
Go.
different.
So take a moment, process through this. The visual helps. The visual helps.
On a line on the refrigerator door.
because in that one you can repeat, and this one you can't.
Yeah.
Yeah.
Which one's that one? Which one's this one?
For
That
this,
one,
you can repeat
this
because there's
one.
A, there's like 2 A's and 3 B's.
Yeah.
And
Yeah.
when you have the letters, you can't repeat because there's only 3 letters.
So the
So-
pile of letters is the permutation.
This list,
I have
1, 2, 3, 4, 5, 6, 7, 8, 9, 27, I think here. And you guys are saying if I make a permutation, an order does matter. How many options do I have?
3 factorial.
Yeah.
3 factorial. Fancy way to say it.
6 times 1.
I think that's all that we need to cover here.
Yes.
Would there be repetition on a, what is it? We're we're picking from 8 people. We're choosing 3 people for president. What are we saying? President, vice president. Sorry, I read too many problems, and secretary. You think that would be a permutation or not? This is one where, like, depending on how you say it, depends on your answers. So what do you think?
Are they saying, like, because it would be a
That's what we're asking.
Yeah, well, because it wouldn't be if you're considering, like, the different specific roles, but, like, it would be, or, I think I'm switching
I
my
don't
words
think it's a
around.
permutation because you can't have, it's a different group of 8 applicants, so it's a different 8 applicants that didn't get any of the other jobs.
What?
So, I mean, unless the different group of 8 applicants can have the people who got president, vice president, or secretary in it, then there's no repetition, so it's not a permutation.
Are you merging 2 situations? So we were just talking about president, vice president, secretary first. Is that a permutation? Can we repeat?
Where's Gunnar? He's been in the bathroom for like 15 minutes.
Don't judge. You don't do
Order matters. Debatable, right? I mean, normally we choose the president first and we work our way down. But can we repeat?
No.
Unless your council would allow somebody to hold 2
That's
offices,
right, it's weird.
which would not be a good idea. But there are some councils where you can have like a big position and then like a minor position also.
It's like a play.
So then, 8 applicants, 3 of whom will be selected to be on the spirit committee. Do they have different roles?
Yeah.
3 of them are going to be on the spirit committee.
Oh, wait.
It's not like president, vice president, and it's just 3 people on the spirit committee, right?
Yeah, there's.
So, is that combination, permutation? What do you think? Combination, because we can have any arrangement.
Could have John, Alice, and Barbara.
Well, they're all women. I don't know why all women, but
I said John.
John?
John,
John Butler.
John is
Maybe.
and
John
Barbara.
is
Maybe
woman
Joanne.
John?
No, John is in like
Maybe it's
J-O-H-N,
Joanna.
like my dad, John.
Maybe Joanna.
Jonathan.
What if we all had our names changed to the opposite gender? What would they be?
Pauline.
Actually,
Colleen.
All right, compare these 2 situations. Hey, compare these 2. Only one of them's a permutation, which is
What? Yeah. Or just Chris. The second one.
So in a permutation,
Yeah.
order
Second
matters.
permutation.
Yeah.
and
No repeating.
no repeat.
So it would be the second one.
So permutation, think of like choosing the numbers from the discs, like and setting them up somewhere. Yeah, and they're gone. You cannot repeat. All right. We are almost out of time. So let's just jump straight to the importance. The nitty gritty. Is there a bigger way that I can show you this? Why is that as big as it is? All right. This is. We already essentially figured this out, but you just don't know the way that it's going to be presented to you. So this general formula is very important because this is how things are going to be presented all the way through your math career. Yes, I know. National Public Radio.
Wait.
NPR means given N items to choose from, you are making R selections.
Isn't that the formula I was talking about?
Yes, but now we've just defined it. So the formula for NPR is N factorial over the difference.
Wait, isn't it with that like that symbol though?
So N N is the number of possible options. P stands for permutation as opposed to C. So, contrary to, like NCR, would be combinations, where order doesn't matter and you can repeat. So we'll talk about that more tomorrow. But we are out of time. So that's your formal formula. Alright. Awesome. Oh, the redo preview from 12.2, because we did get through that as far as we needed to.
Why is 0
I don't know. Let me. That might make sense, but I gotta figure out why it might make sense.
Please figure it out.
I'm gonna do some research.
Wait, so